Hello everyone, my voice is clear to all of you. Can anyone say whether I am clearly audible or not? Okay, so we will wait for a few minutes and let some other students join, then we will start. So, hello everyone. I welcome you all again for this interaction session on atomic and molecular physics. So, like previous session, today we will also solve a few problems which will be based on the lectures of week 2. So, I hope my voice is clear to all of you. So, is there any doubt regarding the previous interaction session? You can raise. So, if you don't have any doubt, then I think we should start with today's discussion. So, is my screen visible to all of you? Is my screen visible to all of you? I have shared the presentation.
Yes, sir.
Okay, so let's start our discussion. So, hello everyone. Myself Vivekananda Nayak. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So today is our second interaction session, and the problems will be based on both week 1 and week 2 lectures of the NPTEL course Atomic and Molecular Physics, which is being flowed this January 2024 session with course code NOC 24 PH04. So continuing our discussion from the last class, now the first question of the day is the amount of electricity that can deposit 1.08 gram of silver from AgNO3 solution is options are 0.15 coulomb, 1 coulomb, 0.01 farad, and 0.01 coulomb. So the question says the amount of electricity that can deposit 1.08 gram of silver from silver nitrate solution, and the options are 0.15 coulomb, option B is 1 coulomb, option C 0.01 farad, and option D is 0.01 coulomb. So if you see here, in options there are both coulomb and Faraday. So kindly notice there are two different units in the answer. So while solving the problem, keep that in mind. So I will give you a few minutes, 1 or 2 minutes, because it's a smaller, it involves smaller calculation. So I'll give you 1 or 2 minutes, then I will discuss the same for you. So is there anyone who has solved it? Can anyone tell me what will be the correct answer in this question? Yes, anyone? Can anyone tell me This question is based on which concept that we discussed in the last interaction session? Yes.
Faraday's law, electrolysis.
Yes. So the current question is based on Faraday law of electrolysis. And regarding Faraday's law, how many laws are there for electrolysis given by Faraday?
2 laws.
Yes. So this problem is based on the second law because it gives the so if you solve it, then from the second law of Faraday law of electrolysis, we know the amount of substance deposited is directly proportional to the equivalent weight of that substance.
Is
So
it 0.01 coulomb?
no, it's not 0.01 coulomb. That's why I told you at the
It is
beginning that
farad. Okay, Farad.
yes,
See,
the
Faraday.
unit will
Farad.
yes, exactly. The option C is correct. The correct answer will be 0.01 Faraday because if you see this problem is based on second law of electrolysis and the law states that the amount of substance deposited is directly proportional to the equivalent weight of that substance. So if you introduce the proportionality constant, then this W will be equals to how much? Q divided by 96,500 into E, where W is the amount of substance deposited and E is the equivalent weight of that substance. So here 1.08 gram of silver is being deposited. So can anyone tell me what will be the equivalent weight of silver?
108 or 107.8.
So for ease of calculation, since you can see the question it is given 1.08 grams, so we will take the for simplicity of for calculation, we will take the equivalent weight of silver is 108 gram. So this is the equivalent weight of silver. So according to this relation, if you see when here Q is in coulomb and 96,500 we know 1 Faraday is equal to 96,500 coulomb, is not it? So if you pass charge of 1 Farad, that is 96,500 coulomb. So here if Q is 96,500, then we see E will be equal to W. So the equivalent weight is defined as the amount of substance deposited when we pass 1 Farad of charge through the solution. So here if you see here W is how much? Here in this problem W is given as 1.08 gram. So if you put the value of W here in equation 1, then from equation 1 we can say that 1.08 will be equals to Q divided by 96,500 into E. If we let me add another slide. So here this Q is in coulomb. So if you convert Q to Farad, then it will be W equals to Q into E, where Q is in Faraday. So what will the value of Q? Q will be W by equivalent weight E. We know from question it is 1.08 gram and equivalent weight of silver is 108 gram. So it will be 0.01 Faraday. Because 1 Faraday of charge gives us equivalent weight amount of substance. So here the correct option will be 0.01 Faraday, that is option C. But if all the options are in coulomb, then you can easily convert Faraday into coulomb. So can anyone tell me if 1 Faraday is 96,500?
965.
So
965.
1 Faraday is 96,500 coulomb. So 0.01 Faraday will be how much? 965 coulomb.
965.
So here the option is, the correct option will be 0.01 Faraday, or if you convert it to coulomb, it will be 965 coulomb. So is it clear to all of you? Yes? Any doubts? So let's come back to our question. So in this question, it was given that the amount of electricity that can deposit 1.08 gram of silver from silver nitrate solution. We know the amount of the substance deposited as a result of electrolysis when we supply or when we pass some quantity of charge, then the amount is right proportional to the equivalent weight. So if you introduce the proportionality constant, it will be Q divided by 96,500, where Q is in coulomb. So if you apply the formula of conversion, then we get 1 farad is 96,500 coulomb, and this 1 farad is the amount of charge which, when flowed through the substance, it will deposit the amount of substance that is equal to the equivalent weight of that substance. So in case of silver, the equivalent weight is 108 gram. So in the question, it is given that we need to deposit 1.08 gram. So 1.08 divided by 108 gram is 1 by 100, 0.01. So exactly 0.01 Faraday of electricity we can pass through the solution of AgNO3, so that 1.08 gram of silver will be deposited as a result of electrolysis. Okay, so the correct option will be option C. Then the next question. Again, this question is also related to the Faraday law of electrolysis. The question says, during the electrolysis of molten sodium chloride, the current required to produce 0.10 mole of chlorine gas using for 2 hours. So here, if you see, there are a few informations in the question. During the electrolysis of molten sodium chloride, so sodium chloride is being used, and we need to find out the current required. We need to produce 0.10 mole of chlorine gas. So can anyone tell me what is the symbol for chlorine gas?
Cl2.
Yes. So what will be the so this is Cl2. So what will be the molecular weight of this Cl2?
2 into 35.5.
Exactly. So it will be 2 into 35.5, which is equal to 71. So the 1 mole of chlorine gas weighs 71 gram. So here we need to produce 0.10 mole of chlorine gas, and we need to find out the amount of current required, and we are flowing the current for 2 hours. So here time period is 2 hours, which is equal to 7200 second, because 1 hour is 3600 seconds. So 2 hours means 7,200 second. And in your calculation, you should take 1 farad equal to 96,500 coulomb. And the given options are 2.68 ampere, 3.30 ampere, 1.57 ampere, and 4.25 ampere. So let's. So I will like you to try this question. Then after a few minutes, I will solve it. So can anyone tell me whether you are being able to access the chat of the Microsoft Teams so that you can post your answers in the chat box itself? Yes, so is there anyone who can see? I just posted a message in the chat of this MS Teams. So can anyone see it? So yes, now coming to the question. Is there anyone who has solved it? What will be the correct option here?
Is
Yes.
it A?
Sorry, I couldn't hear you. Speak once again.
Is it A, sir? A?
Yes, the correct option will be option A, that is 2.68 ampere. Is there anyone who found the correct answer? Yes, anyone? Any other student? Okay, so let's solve this question. So like the previous question, this question is also based on Faraday's law of electrolysis, and we will use the same formula, that is the second law of electrolysis, which gives W equals to Q divided by 96,500 into E. So now here, what will be W? Can anyone say, tell me? What will be the value of W for this particular question? Okay, so see, in this question, it is given the current required to produce 0.10 mole of chlorine gas. So if you see, it is 0.10 mole of chlorine gas, and we know that the for chlorine gas having symbol Cl2, its molecular weight is 71 gram. So 1 mole of chlorine gas weighs 71 grams. So 0.1 mole will be how many gram?
7.1.
It will be 7.1 gram. So here in the question, W will be 7.1 gram. And what is the equivalent weight of chlorine?
71/2.
Yes, so it will be 35.5. So the equivalent weight of chlorine, equivalent 35.5. So if you use the formula, here the time is given and we need to find out the current. So what is the relation between charge, current and time? Charge equals to
I into T.
I see.
I into T. Yes, exactly. So if you put the value of Q here, then we will get W equals to I into T divided by 96,500 into E. So what will be the value of I? Because here we need to find the value of I, and time we know time is 70 to 100 second. Here I will be W into 96,500 divided by E into T. Is not it? So here W will be, we know W is 7.1 into 96,500 divided by 7,200, because 1000 is given, it is time is 2 hours, so which is equivalent to 7,200 second, and then equivalent to it, which is 35.5. So if you solve it, it will come 2.68 ampere. So the correct option is option A. The option is 2.68 ampere. Is this clear to all of you? Yes. Is it? So I request everyone to please participate in the discussion, because the main motive of this interaction session is you need to interact with me so that I will be able to help any doubt if you have in this particular course, or any other, if you want to know about any other things like any other concepts, and definitely I will try my best to clear your doubts. So let's consider. So let's move towards the next question. Yes, the question says a body of density 2.5 gram per centimeter cube and radius 1 centimeter is fully immersed in a liquid of density 1 gram per centimeter cube. The apparent weight of the body will be. The options are 2 gram weight, 2.5 gram weight, 1.5 pi gram weight, and then 2 pi gram weight. So these are the four options, and the question says there is a body which is fully immersed. Suppose this is a container and it has fluids. And there is a body here. So for simplicity, we'll take it as a spherical body. So this body, the density of this body is rho is 2.5 gram per centimeter cube, and the density of this liquid is rho L is 1 gram per centimeter cube. Then it is given that this body and the radius is 1 centimeter. The spherical body of radius 1 centimeter is fully immersed in a liquid. The liquid has a density of 1 gram per centimeter cube, and the body has a density of 2.5 gram per centimeter cube and radius 1 centimeter. So what will be the apparent weight of the body? The options are 2 gram, 2.5 gram, 1.5 into pi gram, or 2 pi gram. So please try this question, and after a few minutes we will discuss. Yes. Can anyone tell me?
Sir, option D, 2 pi gram.
Yes. So this problem is based on a famous principle. What is the name of that principle?
Buoyancy.
Yes. So it
Archimedes
was given by Archimedes principle. Exactly. So whenever a body is partially or fully immersed in a liquid, so the liquid has unique properties. So it will try to oppose the motion of that body in that fluid. So that's why the fluid will oppose a force which will be acting in a direction opposite to that of the direction of the gravity, because always the gravity acts downward. So whenever the body is immersed, so there will be a pressure difference which will be developed at the upper part of the body which is being immersed, or the lower part of the body and the lower part of the body. So due to the pressure difference, so there will be a force which will be acting upwards. So the buoyancy force acts upwards while the gravity acts downwards. So there is another concept. At a certain point, this force due to the fluid or buoyancy force uh, gets balanced by the gravitational force. Then under that case, there is a constant velocity of the body with which the body moves in a fluid. Can anyone tell me what is the name of that velocity? Yes.
terminal velocity.
Yes. So this is Stokes theorem. The velocity will be called as terminal velocity, and it is the theorem is known as Stokes theorem. So now let's concentrate on this particular question. And this question says the body has a density of 2.5 gram per centimeter cube, but the liquid has a density of 1 gram of centimeter cube. So when we immerse the body, since the density of the body is greater than that of the density of the liquid, so the liquid will exert a force, and due to which there will be a change in mass of that body which is immersed in the substance or in the liquid. So uh, then the effective mass will be how much? Effective mass M will be 4 by 3 pi RQ, which is the volume. Then mass is equals to volume into density. So it will be the difference in density of the two substances, the density of the body and the density of liquid. So if you solve it, it is 4 by 3 pi into R is 1. Since all the units are in centimeter and gram, so we will let it be in that system of units. So we'll write it here 2.5 minus 1. So it will be 4 by 3 pi into 1 into 2.5 minus 1 is 1.5. So this is nothing but 4 by 3 pi into 1.5 is 3 by 2. So 3 cancels out and the remaining is 2 pi gram. So this will be the mass of the body which is immersed in the liquid. So if you see here, if you calculate the mass of the body, then this is 1 gram. So original mass was 4 by 3 pi RQ into rho P, but due to the liquid, the density, the density of the liquid is lower than the density of the body. So there is a change in mass, and the change in mass is this factor minus rho L 4 by 3 pi RQ. So can anyone tell me what was the initial weight of the body? It's 4 by 3 pi into 1 into 2.5. That is 4 by 3 pi into 5 by 2 plus 10 by 3 pi. So you see, initially the weight of the body was 10 by 3 pi, but due to the upward force or upthrust of the liquid medium, the weight of the body is reduced, and the effective weight of the body in the fluid medium is 2 pi gram. So I hope this is clear to all of you, or is there any doubt? Yes, so we will continue our discussion to next question. Now the next question says, which of the following forces is not under consideration in Millikan's oil drop experiment? The options are A, viscous force, option B is magnetic force, option C is electrostatic force, and option D is gravitational force. So can anyone tell me what was Millikan's oil drop experiment, or how these experiments was performed? Yes, anyone?
Two capacitor plate, the electric field, like the oil drops were passed through a hole, and since the voltage was applied and the oil started moving upward, so they found the what is the force acting, that is E, a small like charge into electric field minus the mg, and based on that they did the calculations.
Yes, so basically oil drop is nothing but a combination of charged particles, because atoms contains electrons and protons. So since there is a field, so this field will exert some electrostatic force, and this force will be acting in a direction, and the force due to gravity will be acting in another direction, because the direction of the field is such that the force will be acting upwards due to electrostatic force, but the gravitational force will be acting downwards. And since the body is moving in a oil, so here there will be a viscous force. So throughout the experiment, we did not consider a single force out of this given option, and the correct option here will be yes.
Magnetic force.
Yes, so here the magnetic force is not considered. Viscous force is considered because there is a fluid medium, a liquid medium, and gravitational force will be mg, which will be acting downwards, and then there will be electrostatic force, which is the force of electrostatic is F. Is how much? Q into electric field. And can anyone tell me what will be the expression for viscous force? It will be 6 pi eta r.
R V.
So v is the velocity, r is the radius, and eta is the coefficient of viscosity of that medium. So these are the three forces which were taken into consideration during Millikan's oil drop experiment, but the magnetic force was not taken into consideration. So the correct option here will be option B, that is magnetic force. Then is a very interesting question. The question says, a tiny spherical oil drop carrying net charge Q is balanced in still air with a vertical uniform electric field of strength 80 into 10 to the power 4 volt per meter. When the field is switched off, the oil drop is observed to fall with terminal velocity of 2 into 10 to the power minus 3 meter per second. Given acceleration due to gravity small g equals to 9.8 meter per second square, since the oil drop was balanced in a still air, so air also has the viscosity, coefficient of viscosity. So the viscosity of air is 1.8 into 10 to the power minus 5 Newton into second per meter square, and the density of oil is 800 kg per meter cube. So we need to calculate the magnitude of the value Q, that is the charge carried by the oil drop. Here we will ignore the buoyant force, and the options are, option A is 18 into 10 to the power minus 19 coulomb, 32 into 10 to the power minus 19 coulomb, 16 into 10 to the power minus 18 coulomb, and option D is 38.5 into 10 to the power minus 19 coulomb. Yes, so it is a very good question. So I will give you a few minutes, maybe 3 or 4 minutes to try this. Then after 3-4 minutes, we will discuss. I encourage everyone to participate in the discussion because it will be really helpful to you also and also for me. More I interact with you, I will be definitely will be able to discuss more problems and also more concepts. If I have any other new concepts, then I will be encouraged to discuss with you. So I request everyone to participate positively in the interaction sessions, and the preceding interaction sessions, as the course moves on, then the discussions will be more interesting because we will be proceeding towards the model. After from the structure of atom, then we will proceed towards the electronic spectra, then molecular energy levels, molecular spectra, all that. So the discussion will be really important for you, for your exam also, and for your higher education also. Yes, anyone tried it?
Yes, sir.
Yes, so can anyone tell me what will be the charge on that oil drop? Yes.
Please give me some minutes, sir.
Okay, so uh, continue your calculation. Meanwhile, let me discuss the question. Now the question says there is a tiny spherical oil drop which is carrying net charge Q. Suppose let us consider a scenario. This is the scenario. Suppose this is a oil drop. It has a net charge of Q. The charge, the oil drop is balanced and still balance is still air. So this is air medium. We know since the oil drop has some mass, then it will be subjected to the gravitational force, which is mg. Then it is balanced in air with a vertical uniform electric field. So there is a vertical electric field which is applied, and due to which this weight mg is being balanced. So what is the value of that force? So if q is the charge and E is the electric field, the force will be QE. So here the two forces, that is the force due to acceleration due to gravity and the force due to the uniform electric field, are being balanced, because the in the question it says the oil drop carrying net charge Q is balanced. So here there are two forces, the electrostatic force, then it will be, sorry, let me,
QE equal to mg.
so
Sir, it is 38.5 into 10 to the power 19 minus 19 coulomb.
yes, so the correct option will be option D. So we will discuss now. So the force due to electric field is Q into E, and this force is being balanced due to the force of normal reaction is mg. Now here we know the field strength is given. The field strength, that is electric field strength, is 80 into 10 to the power 4 volt per meter. And here the density of the oil is rho 800 kg per meter cube. The magnitude of Q we need to find. We have G, and there is viscosity of air, which is eta. This eta is 1.8 into 10 to the power minus 5 Newton into second per meter square. So now these two forces are being balanced. So this QE will be equals to, mass will be 4 by 3 pi RQ rho, this is RQ rho into G. So this is one equation. So when the electric field is acting, while the field is acting. So when the electric field is acting, this force, these two forces are being balanced. But when the field is switched off, the drop is observed to fall with terminal velocity of 2 into 10 to the minus 3 meter per second. So when the two forces, that is the viscous force and the force due to acceleration due to gravity, is balanced, then under that case there will be a uniform velocity or uniform motion of that object with a velocity which is known as terminal velocity, and the velocity is also given. So if you balance the two, then the viscous force, then in second scenario, the viscous force will be balanced by mg. So this viscous force we just discussed, it will be 6 pi eta rv. Equals to 4 by 3 pi rq rho g. So these are the two conditions. In one case, the electrostatic field is getting balanced by the weight mg, and in the second condition, when the electric field is switched off, then the viscous force is being balanced with the weight mg, and the terminal velocity is 2 into 10 to the minus 3 meter per second. So if there are two equations, this is equation 1 and this is equation 2. If you see, this is 4 by 3 pi rq rho g, and it is similar 4 by 3 pi rq rho g. So here we can say that if you compare the two equations, then it will give us 1 minute. So we need to find the value of q. So in order to find the value of q, if you see here, there are many unknowns, but we know some values. Like we need to find out the value of Q. We know the value of E. We know the value of rho because rho is 800 kg per meter cube. We know the value of V, that is a terminal velocity 2 × 10⁻³ meter per second, but also the value of coefficient of viscosity eta. But if you see here, we don't know the value of R. And in order to find out the value of Q, we need to find out the value of R. So first we will find out the value of R. So there are two equations. In this equation, if you take this equation 1 and equation 2, then from these two equations we can easily find out the value of R. Then it will be R cube will be equal to 3/4 QE divided by pi rho G. This is from equation 1. This is equation 1. Q is equal to 4/3 pi RQ rho G. So here RQ is 3/4 QE by pi rho G. So here R will be 3/4 QE divided by pi rho G to the power 1/3. This is equation 3. So this is equation 4. So we from equation 1 we got one value of R, which is 3/4 QE by pi rho G to the power 1/3. Then from the second equation we can again calculate the value of R. So from the second equation, if you see this one R will be cancelled out, then there will be R square here. So from the equation 2, we can found R is equals to it will be 18 divided by 4, so it will be 9/2. 9/2 into eta V by rho G to the power 1/2. So this is another. So this is from equation 1 and this is from equation 2. So from these two equations we got the value of R. Now we need to equalize to the these two values. So if you compare these two values, then it will be 3/4 QE divided by pi rho G to the power 1/3 will be 9/2 into eta V divided by rho G to the power 1/2. So if we take if you take the power of 1 minute, so if you see here, it is q to the power 1/3 and it is q to the power 1/2. Then if you in both sides we take the power of 6, then one will be power of 2, another will be power of 3. If you let me add another slide. Now we will take the power of 6 in both sides. So we will take it. It will be 6/3 and it will be 6/2. So it will be 3/4 QE by pi rho G. It will be 3/4 QE by pi rho G square will be equals to 9/2 eta V by rho G into eta V by rho G Q. So if you take square here, it will be 9/16 into Q square E square divided by pi square rho square G square which will equal to 9q by 8 into eta cube v cube divided by rho cube and g cube. So here you see, here it is rho square g square and it is rho q g q. So these will be cancelled out. So there will be only rho and g. So if you calculate, then q will be, because here q square and here it is. So if you calculate, let me, is q square and it is, this is q square and this is q square. So q will be 9 cube divided by 8. Sorry. It will be 9 cube by 8 into rho q v q by rho g into 16 by 9 into pi square divided by e square. Square root. So if you put all these values, like we know all these values are known to us. E we know the value of E is 18 to 10 to the power 4. Then we know the value of rho, we know the value of V, and we know the value of G. If we put all these values, the correct answer will be, as someone mentioned, it will be option D, that is 38.5 into the power minus 19 coulomb. 38.5 into 10 to the power minus 19 coulomb. So this will be the charge on the oil drop. Let me explain it to you once again. So in this question, it is said, it is given that there is an oil drop which is carrying a net charge Q, and at a instant of time, the oil drop is balanced in air by means of a vertical uniform electric field, which is balancing the its weight, which is equals to mg. So when the electric field is present, then the electrostatic force is being balanced by the gravitational force, and when the field is switched off, the drop is observed to fall with terminal velocity. So when the object is falling with terminal velocity, then and the electrostatic field is switched off, so the two forces which are being balanced is the gravitational force and the viscous force. So in the second case, 6 pi eta rq will be equal to 4 by 3 pi rq rho into g. So if you consider the two equations, from both the equations we can find the value of r, and then equating the value of r we can find the value of q. So this is a tricky question, and the value of q gives us, the value of q is this. If you put all the known values in this equation, because there is all known values, so and q is only one unknown. So if you put all the values, we will get the value is 38.5 × 10 to the minus 19 coulomb. This is the answer. Let's. So is there any doubt in the previous question? Yes, anyone? Okay, so let's consider the next question. Now this question says, what will be the shortest wavelength of continuous X-ray if the applied voltage between cathode and target is 3.1 kilovolt? And the options are option A 1 ampere, B 2 ampere, option C, sorry, not ampere, Armstrong. Option 2 is 2 Armstrong, option C is 3 Armstrong, and option D is 4 Armstrong. So here this question is based on X-ray, and the applied voltage is 3.1 kilovolt. What will be the wavelength of the continuous X-ray? Yes. So can anyone tell me how we will solve this problem? So if you consider the X-ray spectra, and this is intensity and this is wavelength, then the X-ray spectra is like this. So there is a minimum value from which the X-rays emission starts. It is lambda minimum, and we here need to calculate this value of the shortest wavelength. So this is continuous X-ray. And there is another one which is called as characteristics X-ray, which is like there will be some peaks here. So in the latter part, we will discuss about X-ray in more details. But in the present session, let's continue to solve this question. So yes, can anyone tell me what will be the shortest wavelength here? So if you so simply we can say we know energy is h nu, and since there is a X-ray, it has some wavelength lambda. So in terms of wavelength, it will be hc by lambda, where c is the, since X-ray nothing but electromagnetic radiation, and the velocity will be 3 into 10 to the power 8 meter per second. So in that case, we know this E is energy, and here the applied voltage between cathode and target is that 3.1 kilovolt. So the energy will be equal to 3.1 kilo electron volt, because the electron is gaining energy. So one electron charge into this 3.1 kilovolt will be 3.1 kilo electron volt. So if you convert it to joule, then it will be 3.1 into 10 to the power 3 into 1.6 into 10 to the power minus 19 joule, which will be equal to hc by lambda. And we need to find out the value of lambda, which will be hc by this value. So but there is a formula which also acts as a shortcut to calculate all this. So if you consider the wavelength in terms of in units of Armstrong and the energy or the voltage difference in terms of volt, then there is a formula which directly gives us in terms of Armstrong is 12,400 divided by the volt. Because if you see here, it is nothing but E into V, and here it is hc by lambda. So if you put lambda in terms of Armstrong and V is volt, then the equivalent value of wavelength will be 12,400 divided by V. So simply, if you put here 12,400 divided by 3.1 into 10 to the power 3. So it will be how much? It will be 4 Armstrong. So the correct option will be option D. Is this clear to all of you? Yes? Is this clear to all of you? How I told
Yes.
you that there is a, so there is a formula. You can also calculate in this way. I told just now. Like if you convert the energy in 3.1 kilovolt is equal to 3.1 into 10 to the power 3 into, if you convert electron volt to joule, it will be 1.6 10 to the power minus 19 joule. So if you put all these values, you will calculate the value of lambda, which will be coming in terms of meter. Then we will convert it into Armstrong, because the options are given here in Armstrong. So but there is a formula which has been derived. If you put the value, if you want the value of lambda in terms of Armstrong, we can simply put the value of voltage through which it is being accelerated, because here we have put the value of voltage 3.1 into 10 to the power 3. So we can simply put the value of voltage here, and then there will be 12,400 in the numerator. So in that case, if you use the same formula, it will give you 12,400 divided by 3. It will be 3,100. Simply it gives us 4 Armstrong. And also, if you can even tell me, if the value of lambda here, I change the value of lambda to nanometer. So what will be the expression here in the right hand side?
0.4.
No. What will the expression
Acha.
like here? here it is 12,400 divided by V. Then what will be here in this case if we want to find the value of lambda in terms of nanometer unit?
Just 1 0 we have to remove.
Yes, so it will be 1240 by V. This will be, so if the options are given in terms of nanometer, then you can use this formula. If the options are given in terms of Armstrong, you can use this formula. Then question number 7, the question says, calculate the minimum voltage which must be applied to an X-ray tube to produce continuous X-ray photons of wavelength 0.5 Armstrong. So this is pretty much simpler if you compare it to the previous question. So we can the same formula we can use it. So please solve it and tell me what will be the minimum voltage we need to apply in an X-ray tube so that we can produce continuous X-ray of wavelength 0.5 Armstrong.
24800.
Yes, any other student who has calculated it? The correct option will be option B. That's mentioned 24800.
Yes, sir. Option B.
Yes, so if you see here, the same formula we know, lambda in terms of angstrom is equals to 12,400 divided by how much? V. So it is 0.5, which will be 12,400 divided by V. So V will be simply 12,400 into 2, which will be 24,800 volt. So this formula will be, so this V, applied voltage V, so the applied voltage V will be 24,800 volt. Then the next question. So before discussing a few questions, so now let's discuss briefly about the structure of atom and basically the structure of hydrogen atom, which was given by Bohr. And in the preceding problems, we'll be using this formula. So I thought that why not we should discuss these formulas a bit and then we'll continue our problems. Then if you know, in case of Bohr's atomic model, he said that there are two forces because in the previous model which was given by Rutherford said that the can anyone tell me what was the limitation of Rutherford's atomic model?
Stability of atom.
Yes, exactly. So in case of Rutherford's atomic model, he said that the electron is moving around the nucleus in certain circular orbits or energy levels. And we know, according to the Maxwell's theory, whenever a charged particle is getting accelerated, so it will emit electromagnetic radiation. So as it emits electromagnetic radiation, then the radius of that orbit will be decreasing continuously. Then after a certain amount of time, it will fall onto the nucleus and atom as a whole will be destroyed. So there will be no existence of the atom, but actually atoms are existing in the nature. So the model or the hypothesis that was given by Rutherford was not considered in terms of stability. So but here Bohr said that as long as the electron moves around the nucleus in a certain circular or any orbit, there are two forces, which is the electrostatic force of attraction between electron and the nucleus and there is another force which is responsible for circular motion, which is centrifugal force. So he balanced the two forces. One force was mv square by r and another force was the electrostatic force of attraction between electron and the nucleus. So from these balancing the two forces, he derived a number of parameters for the electron, like the radius of that nth orbit, which was given by n square s cross square by pi m jd square. Also we can write it as n square h square epsilon 0 by pi m jd square. So please notice here that it is h cross, where h cross is h by 2 pi. So here if you write it in terms of h, it will be n square h square epsilon 0 by pi m jd square. So can anyone tell me what is the value of h? We all know h is Planck's constant. What is the value of h?
6.62 into 10 to the power minus 34 joule second.
Exactly. So this is the value of Planck's constant, and this Planck's constant is very important in quantum mechanics, because in case of quantum mechanics, all the quantization are a result of this Planck's constant. If the constant value is 0, then the whole quantum mechanics will be converted into classical mechanics basically. So like similarly, we Bohr also gave the expression for velocity of the nth orbit, which is jd square by n h cross, or we can write it jd square by 2 epsilon 0 nh. And then the energy of the nth orbit, which is, we also can write minus 1 by 8 m z square e fourth by n square h square epsilon 0 square. And if you see, as long as the electron is moving in an orbit, its energy remains constant. But when there is any energy change in the electron, then it jumps from higher to lower orbit, or it when it absorbs energy, it jumps from lower to higher orbit. So in between the transition, whether the radiation is emitted or radiation is absorbed, it will depend upon the energy difference between the two energy levels. So whenever the electron absorbs energy, it jumps from lower energy levels to higher energy levels, and when the electron emits energy, it jumps from higher energy levels to lower energy levels. And the expression for the wavelength is 1 by lambda, which is in terms of wave number, which is nu prime or nu bar, which will be r into 1 by n1 square minus 1 by n2 square. So n1 is the initial orbit from which the electron jumped, and n2 is the final orbit. And here r is a very well known constant, which is known as Rydberg constant, and it has the unit of centimeter inverse. And if you see, basically mainly Bohr gave the model mainly for hydrogen atom or hydrogen like atom who have only one electron. So in that case, if you see, this is an representation of hydrogen spectral. This is, if you see, there are energy levels n1, n equal to 1, n equal to 2, n equal to 3. Like that, there are n equal to 4 and n equal to 5. So whenever electron jumps from any other higher orbit to n equal to 1 orbit, the energy difference is emitted in terms of radiation, and this radiation belongs to Lyman series of spectral line. And similarly for n equal to 2, when the electron jumps from any other higher orbit, this is called as Balmer series. And then for n equal to 3, it is Paschen series. Then for n equal to 4, it will be Pifford, and then for n equal to 5, it will be Hamper. So there are different series, but most important series is Balmer series, because it is lies in the visible region. And if you see, there are different components of Balmer series here, which has been represented. So the maximum wavelength corresponding to which contain Balmer series containing maximum wavelength is 656.3 nanometer, which corresponds to red region. So this is the red line. And then there is a blue-green line, which corresponds to the transition from n equal to 4 to n equal to 2. Then from n equal to 5.6, the transition give us violet lines, which is here. So as we go on, as we go away from higher to higher levels, the wavelength decreases. So if you see here, the Lyman series is in ultraviolet region, but the Balmer series in visible region, and the Paschen series in infrared region. So as we go away from the energy levels, then the wavelength of the series goes on increasing. because ultraviolet region is lower wavelength, infrared region is higher wavelength. So this is a brief introduction to different energy levels of hydrogen, and it is hydrogen spectra. So can you tell me whether it is emission spectra or absorption spectra?
Emission.
Yes.
Emission.
Yes, because in case of absorption spectra, there will be some blank lines. Like if you supply energy to electron in the hydrogen atom, if it absorbs that particular amount of wavelength, then in case of the result, you will find that that region of the wavelength is being absorbed. So it will appear as blank. But in case of emission spectra, there will be spectral lines which will be appearing at certain places. But in case of emission spectra, in case of absorption spectra, the lines will be uh, uh, blocked from a particular region. Okay, so we will continue our discussion. Now the question says, which of the following transitions in a hydrogen atom would emit the longest wavelength photon? Yes, the question says, which of the following transitions in a hydrogen atom would emit the longest wavelength photon? The options are n equal to 2 to n equal to 1, n equal to 3 to n equal to 2, n equal to 5 to n equal to 2, and n equal to 6 to n equal to 2. Yes. Yes, can anyone tell me? So if we discuss, so like here, if you see here, the Lyman series corresponds to ultraviolet region, which is of shorter wavelength. Now, as we move away from the nucleus, the other series have longer wavelengths. But if you see here, Generally, the expression for wavelength, as we have discussed, it is 1 by lambda. So it is 1 by lambda is equals r square 1 by n1 square minus 1 by n2 square. So for lambda to be large, this value should be small because there is reciprocal of lambda, that is 1 by lambda. So here we need to find for which case 1 by n1 square minus 1 by n2 square is the smallest. So n equal to 2 to n equal to 1. So in first case, it will be 1 minus 1 by 4. Second case, it will be how much? 1 by 4 minus 1 by 9. It will be 1 by 4 minus 1 by 25. Then it will be 1 by 4 minus 1 by 36. So here out of these four values, if you see here 1 minus 1 by 4, this value will be 3 by 4. Then here for B, it will be around 36
5
by
by
5.
5 by 36.
Sorry, yes. It will be 5 by 36. Option for option C, it will be how much?
21 by 100.
21 by 100. And option D will be
Again 5 by 36.
no, it will not be 5. Here it is 1 by 4 minus 1 by 36. So it will be 8 by 36.
36. 9. Yes.
9 minus 8 by 36. So if you see out of all these four values, the minimum is, which one is the minimum value?
First one.
First one, 3 by 4 is less than 5 by 36, we are saying.
No.
Here 3 by 4 is also present. Na? This is option A. 3 by 4, 5 by 36, 21 by 100 and 8 by 36.
Option B is correct.
Yes, so option B is the smallest. So this option B, n equal to 3 to n equal to 2, corresponds to the longest wavelength of photon. So now if you refer to the previous figure, here you see this first option A corresponds to Lyman series, and all these three are corresponding to Balmer series because n equal to 2 here. Now if you see in case of Balmer series, here this is n equal to 3 to n equal to 2, which is 656 nanometer. Then the second one is 486 nanometer and the third one is 434 nanometer. So if you see out of these three values, the longest wavelength corresponds to a transition from n equal to 3 to n equal to 2. So n equal to 3 to n equal to 2 has the longest wavelength of the Palmer series also, and in the in this question also the longest wavelength will be corresponding to n by 3 to n equal to 2. So now let us consider Balmer series only. So can anyone tell me? We found that n equal to 2 to n equal to 3. Sorry, it will be n equal to 3 to n equal to 2 transition corresponds to longest wavelength. So can anyone tell me which transition will be corresponding to largest wave, correspond to smallest or shortest wavelength? Now this one corresponds to largest lambda. So then which transition in the Balmer series corresponds to smallest lambda? Yes. So if you see here,
The D option.
sorry,
The D option here, 4.5.
no, I'm not talking about these three options only. I'm saying in terms in Balmer series, the whole Balmer series, like n equal to 3, 4, 5, 6, 7, 8 up to infinite. So which of the
From
which of
infinite
the
to 2, it will be small.
exactly? So from infinity to 2, because if you see for this value to be small, this value needs to be large. So all these expressions, something is being subtracted to 1 by 4. So for the value 1 by 4, the largest value will be 1 by 4 minus 0, and this 0 corresponds to 1 by infinite. So for n equal to infinite, if the transition occurring from n equal to infinity to n equal to 2, the wavelength will be shortest. Next question. The question says, what will be the shortest wavelength in the Paschen series of hydrogen spectrum? So similarly, just tell me what will be the values of n for the shortest wavelength of the Paschen series. Now we know
N to
for
infinity to 3.
Paschen series n2 is 3, but n1 will be how much? How we need to calculate? Similarly, here it is 1
It
by
will
4
be
minus
infinity.
other values. So here will be 1 by lambda will be r into 1 by 9 minus 1 by n1 square. So this value need to be large or largest for lambda to be test. So 1 by 9 minus 1 by n1 square should be largest, and this value corresponds to 1 by 9 minus 1 by 0. So this 1 by infinity. This is 1 by infinity. So this infinity corresponds to n equal to infinity. So everyone understood it clearly? How the shortest wavelength and the longest wavelength has been calculated?
Shortest.
So can anyone tell me which transition will corresponds to the largest wavelength in Paschen series only?
4 to 3.
Exactly. So for Paschen series, large lambda will corresponds to n equal to 3 to n equal to n equal to 4 to n equal to 3, and smallest lambda will be corresponding to n equal to infinity to n equal to 3. So now we need to find out the value of that wavelength. So we simply need to put the value of r, and the value of r is already given here. It is 109793 centimeter inverse. So simply you can put the value of r. So 1 by lambda will be r into, for shortest wavelength it will be only 1 by 9. So r into 1 by 9, or lambda will be 9 by r. It will be 9 divided by r is how much? 109793 centimeter inverse. 109793
Okay.
centimeter. So it will be how much? If you calculate it, it will be coming around 80.
82, 8200, 8197.
Exactly, in terms of
20.
Armstrong, because the options are given in terms of Armstrong.
8200. Option C.
Yes, so it will be 82 Armstrong. So this is the answer of which question? Question 9. This is question 9. So this is answer of question 9. Correct option will be option C, which is 8200 Armstrong. Then question number 10. an electron in ground state of hydrogen absorbs 13.056 electron volt of energy. What will be the increase in its angular momentum? So here it is given the energy absorbed by the electron is 13.056 electron volt. Then we need to find out the angular momentum, and the symbol for angular momentum is L. So I will give you a few minutes to try this question, then we will discuss. Yes, so can anyone tell me what will be the increase in its angular momentum? So we know En is minus 1 by 8 n square s square epsilon m z square sorry. Z square e fourth by n square s square epsilon 0 square. So corresponding to this, E1 is minus 13.6 electron volt. Then similarly E2 will be minus 13.6 divided by 4. E3 will be E1 by 9, like that. So you know this E1 is minus 13.6 electron volt. So, but here it is given that an electron in ground state of hydrogen atom absorbs 13.056 electron volt of energy. So E1 is now let's consider only positive sign, because the energy is negative because it is a bound system, that is the electron is being attracted towards the nucleus. So for the attractive force, the energies are always negative. So it is minus 13.6. So now for this particular question, let's forget about the sign of the energy. So E1 is 13.6 and the electron absorbed energy 13.056. So the energy absorbed is 13.056. So what is the difference of energy? It is 13.600 minus 13.056, which will be how much? 0.4454. Sorry. Is this clear to all of you? Hello, am I audible to all of you?
Yes.
Okay, so let's continue our discussion. So the ground state energy is 13.6 electron volt, and the energy that electron absorbed is 13.056 electron volt. So the difference in energy is 0.544. So this 0.544 must correspond to some energy level, because if the electron had energy initially at ground state, it had energy 13.6 electron volt. But when it absorbed the energy 13.056 electron volt, so the electron will travel from lower energy level to higher energy level, and the difference in the two energy values 13.6 and 13.056 will be equal to the final value of the energy when the electron is present. So the difference in energy 0.54 per electron volt is the energy value of the orbit where the electron is currently present after absorbing the energy of 13.056 electron volt. So if you want to find which energy level has the energy value of 0.54 per electron volt, simply we can divide 13.6 by 5.544. Is not it? Is this clear to all of you? Like here we are dividing for second energy levels minus 13.6 by 4. Then E4 will be how much? Minus 13.6, which is E1 by 16, like that. So if you divide 13.6 by 0.544, it will be coming 25. So this 25 corresponds to n square, because at each energy level, the 13.6 is being divided by its square values. So for E5, it will be 13.6 divided by 5 square. So now the electron is at n equal to 5. Initially it was at n equal to 1, which corresponds to 13.6 electron volt, and the same electron absorbed energy of 13.056 electron volt, and it reached the energy level n equal to 5, which has energy 0.544 electron volt. So what will be the change in its angular momentum, or what will be the increase in its angular momentum? So we know, according to Bohr's theory, the angular momentum, which is equal to mvr, which is also where L is equals to n h cross, or n h by 2 pi. So for n equal to 1, L will be h by 2 pi, and n equal to 5, L will be 5h by 2 pi. So what is the change? So the change in angular momentum will be 5h by 2 pi minus h by 2 pi, which will be 4h by 2 pi, It will be 2h by pi. So the correct option will be option B. Is this clear to all of you?
Yes, sir. Yes.
So can anyone tell me what will be the energy level if the electron absorbs 13.6 electron volt of energy?
One only. Ground.
No. If the ground state of electron is 13.6 electron volt, if we
Zeros,
provide this
infinity.
amount of electron, then the energy difference will be 0.
Infinity.
So n will be infinity. So infinity means it is at a very large distance from the nucleus where it can't experience any force, because the force between nucleus and the electron is electrostatic force, and the electrostatic force is right proportional to 1 by r square. When n is at infinity, r will be at infinity, then r square will be also infinity, so 1 by r square will be 0. So the force between electron and nucleus will be 0. So in that case, the electron will considered to be free. That is, the atom is ionized. So if we want to ionize the hydrogen atom, we need to supply 13.6 electron volt of energy, and that energy, when the electron absorbs that energy, it will move from n equal to 1 to n equal to infinity. That is very far away from the nucleus. So the ionization energy of hydrogen is 13.6 electron volt. Then, so is this clear to all of you, or I need to explain it again? Okay, so let's discuss our next question. Hopefully this will be the last question of today's interaction session. The question says the ratio of radius of an electron in third orbit to that of fifth orbit in hydrogen atom is. So can anyone tell me what is the expression for radius of the orbit in which an electron is moving? Yes. Can anyone tell me what will be the radius of a stationary state or energy level in terms of according to the Bohr's theory?
N square h cross square by mz e square.
Yes. So if you see here, the only variable here is n and z. So r is directly proportional to n square, because z is 1 for hydrogen. So Rn is n square h square epsilon 0 by pi m z square. Suppose for R1 will be how much? H square epsilon 0 by pi m z square, and for z equal to 1, this value will be h square epsilon 0 by pi m square, which is called as a0, and this is called as Bohr radius. Bohr's radius, and this is the radius of the ground state of hydrogen atom. Can anyone tell me what will be the value of Bohr's radius? It is 0.53 angstrom. Is not it? So this is the ground state radius. Then similarly, this is given third orbit n equal to 3 and fifth orbit is n equal to 5. So in terms of Bohr radius a0, r3 will be n square a0, which is 9 a0, and r5 will be n square a0, which will be 25 a0. So the ratio will be how much? The ratio will be 9 is to 25. So the correct option will be option C. Is this clear to everyone? Yes. So is there any doubt in the in the last question or any other question that we have discussed today? So let me. So we will conclude our introduction session today. Then in the next session, we will discuss a few problems related to the blackbody radiation, and then the other part that will be covered in the lectures of week 3. So is there any doubt regarding anything regarding today's session, previous session, or any other thing that I'll be definitely happy to clear it? Then if no one has any doubt, so we will conclude our today's session. So thank you all again for joining in this session. So in the next session, we will be discussing a few more problems or a few more concepts that has been covered in the lecture sets of week 3. So that's it for now.
Thank you, sir.
Okay.